So this is our subject, advanced machine learning, and in unit 1 we have feature vectors, feature extraction, learning problem formulation, then types of machine learning algorithms, parametric and non-parametric machine learning algorithms, supervised, unsupervised, semi-supervised, reinforced learning algorithms, linear algorithms such as linear regression, logistic regression, linear discriminant analysis. This is from unit 1. This is from unit 1. So let us take few basics, and we are referring this book as told for today's session, Master Machine Learning Algorithms by Jason Browley. So few basics we'll take. So here, as you can see, we are categorizing our learning algorithms, we are categorizing our machine learning algorithms as linear algorithms or non-linear algorithms. If it is a linear algorithm, what can be the examples of linear algorithms? Linear regression, which is used for predicting the values. Logistic regression, which is used for classification with two categories. Linear discriminant analysis, which is used for classification when we have more than two categories. Gradient descent optimization. So all these fall under linear algorithms. Coming to non-linear algorithms. Which algorithms may be called as non-linear algorithms? K nearest neighbor can be a non-linear algorithm. Its extension called as learning vector quantization can be a non-linear algorithm. Decision tree algorithms, regression trees, classification and regression trees, naive Bayes, all these fall under non-linear algorithms, including the support vector machines. So we have linear algorithms such as linear regression, and we have non-linear algorithms such as support vector machines. We also have something called as ensemble algorithms. Whenever we refer ensemble algorithm, what is the meaning of that? Okay, it will be combining. What it will be combining? The ensemble algorithm will be combining the predictions. It will be combining the predictions from what? From multiple models. From multiple models for better predictions. Whenever we speak about ensemble algorithms, which algorithms comes into our mind? Bagging algorithm, random forest algorithm, boosting ensemble, ADA boost algorithm. Okay. So these are few of the ensemble algorithms which are referred. So whenever we are speaking about machine learning algorithms, they have a statistical learning perspective. What is that? You have an output variable which needs to be predicted, and there is a function which will be operating on the input vector. So the output variable which needs to be predicted can be called as a dependent variable, and the input vector can be called as an independent variable. So if this is the relationship, this relationship can be mentioned as y is equal to f of x, and this kind of relationship is a kind of machine learning which is called as predictive modeling or predictive analytics. So here what is there? If the relationship is y is equal to f of x. So this relationship can be mentioned as output attribute is equal to program in the bracket input attribute. But we usually get confused between what exactly is a model, what exactly is an algorithm. So the algorithm will be operating on the data, resulting in a model. So they will be, the machine learning algorithms basically will be learning a target function that will be best mapping the input variable x to an output variable y. So you have an input variable x and you have an output variable y. So this relationship y is equal to f of x. Okay. So if somebody asks you how to define machine learning algorithm, what you should say? It's a technique which will be estimating the target function, which will be estimating the target function f to predict the output variable y given the input variable x. So that's why the relationship y is equal to f of x. But you also have something called as y is equal to f of x plus e, where this e is an irreducible error. So we have seen what? The statistical perspective, the linear algorithms, the non-linear algorithms. Similarly, Your algorithms can be organized, your machine learning algorithms can be organized as either parametric machine algorithms or non-parametric machine algorithms. Okay. So what may be a parametric model? What may be a parametric machine learning algorithm? Okay. So this model will be summarizing the data with the help of fixed size parameters. Fixed size parameters. That's why it's a parametric model. Okay. Say for example, you want to draw a line, you want to map a line, and you are applying linear regression. So mapping function to a line. So you have this linear relationship called as b0 plus b1 x1 plus b2 x2 is equal to 0. Here you know that b0, b1, b2 are the coefficients of the line. Okay. Who will be controlling the intercept and slope, while x1 and x2 will be the input variables. So this kind of algorithms fall under the category of parametric model. Parametric model. Which are the example of parametric machine learning algorithms? Your logistic regression is parametric machine learning algorithm. Perceptrons are parametric machine learning algorithms. Logistic regression, linear discriminant analysis, these all come under parametric machine learning algorithms. So why we go for parametric? They're simpler, good speed, they operate on less data. What may be wrong with the parametric machine learning algorithms? Okay, so they are highly constrained because they'll be having a fixed set of data. They have limited complexity. They are poor fit. Okay, so this is all about the parametric machine learning models. Coming to the non-parametric machine learning models. Okay, so the non-parametric machine learning models, which are the examples of non-parametric machine learning algorithms, decision trees like CART C4.5, naive Bayes algorithm, support vector machines, neural networks, all these come under non-parametric methods. Okay, so what may be non-parametric methods then? Okay, they will not make any strong assumption about the form of the mapping function. Okay, as they are not making any assumptions, they are free to learn any function from the training data. Okay, these will be good when you have a lot of data, when you have no knowledge. So all these fall under non-parametric methods. All these fall under non-parametric methods. Why we go for non-parametric machine learning algorithms? They are more flexible, they have more power, they have more performance. What may be the limitations of non-parametric machine learning algorithms? They require more data. They are a bit slower and overfitting. These are the limitations or disadvantages of your non-parametric models. Non-parametric models. So, if you look at linear regression, it was falling under which category? Let us look at. Linear regression falls. Linear regression fall under linear algorithms. Linear regression fall under linear algorithms. So what we spoke about linear regression, we know that linear regression, a simple linear regression will be predicting the scores on one variable from the scores on the second variable. The variable being predicted is called as the criteria variable and it is given as y. And the other variable is given as x, which is called as the predictor variable, which is x. Okay. So if you look at simple linear regression, this is what it is. Y is equal to ax plus b. This kind of relationship will be there, where x will be the independent variable, predictor variable, explanatory variable. Okay. So you have a and b as slope and intercepts, and the relationship is y is equal to ax plus b, and the relationship is y is equal to ax plus b. While the y variable is called as a response variable, criteria variable, dependent variable. Okay, and basically linear regression deals with what? It actually uses statistics. It establishes a relationship between two variables. It establishes a relationship between two variables. So let us say I have these variables x and y, and I have mapped these values for this x and y as 1, 2, 3, 4, 5 and some values for y. What I did here is, you can see here I calculate the mean of x, mean of y, standard deviation of x, standard deviation of y, then correlation I calculated. Once I calculate the correlation, I can calculate the slope and intercept using these formulas. Slope will be calculated, B will be calculated as R multiplied by standard deviation of Y by standard deviation of X. While intercept will be calculated as a mean of Y minus slope multiplied by mean of X. Once you do that, you will be establishing a relationship. What relationship? This Y is equal to AX plus B relationship will be established. Once you do that, suppose you have a new value for X, then you can predict the new value for Y. This is what in a nutshell about linear regression. So this is what in brief I wanted to convey